Let's talk about where and when, coordinate systems and seasons. Topics we will discuss today include the night sky, observing it, and the year, including seasons. It's safe to assume that humans have always been fascinated by the stars in the sky. When communicating to one another where different stars were in the sky, it's useful to envision a model called the celestial sphere. Think of it as a dome surrounding you completely, almost like a planetarium. And the stars are located at different points on the inside of the planetarium walls. Naturally, this is not a real, physically real thing. However, it's used as a tool for us to talk about where the location of stars are and how they are moving. In reality, stars are located at various distances from the Earth. And because the Earth is rotating, they appear to move around the Earth in the course of a night. When we talk about the celestial sphere, we can talk about different points related to where things are. When you are standing at some point on the Earth, then the zenith is directly above the top of your head. The opposite of the zenith, the nadir, is below your feet. The north and south celestial pole are, as the names imply, to the north and to the south. And the celestial equator goes around where the equator would go on the Earth. In the sky, we see many constellations, many patterns, that is. Patterns of stars are sometimes referred to as constellations, sometimes asterisms. The difference between the two is that there are 88 internationally recognized constellations, which refer to entire patches of the sky with the patterns of stars in them. Asterisms, on the other hand, only refer to the collection of stars that form a pattern. These may be subsets of a constellation, or they may encompass a couple stars from one constellation and some stars from another constellation. The best way to view the stars is under very dark skies, but where you are on the Earth will have an effect on which stars you see. The same stars are not all visible in the northern hemisphere that are visible in the southern hemisphere. Just as we do with a globe, we can divide up the celestial sphere into a grid of latitude and longitude lines. We refer to the lines of latitude on the celestial sphere as declination, and the lines of longitude we refer to as right ascension. The diagram shows the way these latitude and longitude lines are traditionally numbered. You notice, for example, that a right ascension of 0 hours and 0 minutes is the point of where the vernal equinox is. Vernal meaning spring. This is where the sun would be located during the spring equinox. As we've said, the best way to view the night sky is under dark conditions. However, even if you are in a light-polluted region, you should still be able to see many stars. And some very bright constellations will be obvious to you. You can familiarize yourself with them, and they will become easier and easier to spot with practice. Though some people believe the northern star to be a very bright star, it is actually not particularly bright. However, you can help yourself find it by finding the Big Dipper, which is a very obvious constellation in the sky. The Big Dipper's bowl helps point to the North Star, or Polaris. In case it's not obvious to you that stars appear to move across the sky, you can try a little trick for yourself. Look through a window at night and mark with a wax pen where a star is located. Go away and come back in about 15 minutes. Put your head in the same location, and you will see that the star is no longer where your marking is. Because humans imagined the patterns in the sky to have significance, they also made up stories to go along with the constellations in the sky. Greeks, for example, imagined great gods, warriors, and other things in the constellations of the night sky. What happens during the course of a year? We take a trip around the sun. During that trip, the sun appears to be in a certain point along an imagined belt, which is called the ecliptic. This is the premise behind the idea of astrology, that the sun is quote-unquote in a particular situation, particular constellation. The idea that this has any meaning to human lives is the basis for astrology. Astrology is not a science. Astrology is a pseudoscience. It has no basis in fact. We will watch a video that debunks the weaknesses of the claims of astrology. The Earth is tilted with respect to the ecliptic. We are at 23.5 degrees if you were to draw an axis of rotation. It is this tilt that actually causes the seasons on the Earth. When, in the northern hemisphere, we are tilted towards the sun, it is summer. Notice at the same time that in the southern hemisphere, they are tilted away from the sun, meaning that it is winter there. The exact opposite occurs 6 months later, when the northern hemisphere is tilted away from the sun, receiving less direct sun rays, and meanwhile the southern hemisphere, experiencing summer, is tilted towards the sun, experiencing more intense direct sun rays. This tilt also causes more daylight hours to occur when we are tilted towards the sun, and fewer daylight hours to occur when we are tilted away from the sun. We will also watch a video related to the seasons. There are many misconceptions about what causes seasons. People think that we are actually located closer to the sun in the summertime and that's why it's warmer. If that were the case, then the entire Earth would be warmer, not just the northern hemisphere. And it turns out that in the northern hemisphere, the exact opposite is true. The Earth is actually closest to the Sun in the wintertime, not the summer. It is only the tilt of the Sun, which is responsible, the tilt of the Earth, which is responsible for the seasons. As we mentioned, there are important effects of the tilt. More heat gets directed in the summertime because the rays of sun hit us more directly. Whereas in the winter, the beam is more spread out and the rays hit us more indirectly. We also have longer days in the summertime than we do in the winter. Because in the winter, tilting away results in it not taking as much for the sun to sink below the horizon. In the spring and fall, we have equal days and nights, and the sun appears to be about in the middle of the extreme locations that it sets at in the summer and winter. In the summer, the sun sets in the most northerly part of the horizon at your location. In the winter, the sun sets at the most southerly location of the horizon. Another phenomenon that happens with the Earth is that it wobbles. Instead of remaining steady on its axis, you could think of it as a spinning top which is losing speed and starting to wobble. This precession changes what stars are pointing north over a currently predictable period of 26,000 years. Though currently Polaris is our North Star, the closest star to celestial North Pole, in AD approximately 14,000, the North Star will no longer be Polaris, but will instead be Vega. Here's an example of where the North Star would be throughout time. The red circle indicates at what point the celestial North Pole is pointing at different points in time. Today you see the red line nearly intersects Polaris, which is why we call it the North Star. In 8000 CE, we will be in the Cepheus constellation. That will be celestial north. And in 14,000, we will be close to Vega. On the other hand, 4000 BC, the celestial North Pole was near Thuban in the constellation Draco.